Help me help you. I need a minute.
Okay. Looks like we are live, I guess. So let's all go to that good old quiz.
All right, nobody has any questions, so we should be good to go.
Okay.
Group meeting quiz.
Group meeting quiz.
Oh, this is the one I started last night, wasn't it?
Right.
Yeah, Tuesday.
It's not fair. You got a head
No,
start.
Tuesday. No.
You
Yeah,
probably
but
got a head
questions
start
one
on
and two,
question
right?
1 and 2.
Yep, they're both done.
Man,
When
cheater.
I saw question 3, I had a heart attack.
Okay, it says do not round until your calculation is complete. That's normal.
All right, so you guys got this one? Use the normal probability applet. So everybody have their applets up.
Yeah, got mine up.
So then we're looking for the areas to the right and to the left of 1.358. So you put that in there, and then you shade the right and the left blue, and everybody get.
I got 0.1745.
0.175.
How many digits do we round to?
3.
Round your answer 3. Okay, 175. So what everyone's got?
Brandon, do you guys got that on your applet?
I just feel that's where we're at. Okay.
I didn't do it yet.
Okay. Bring up your normal probability applet, and I think it's also a link on the quiz.
Let's see, normal probability.
1.358. And what was the question?
Then you want to shade. It says you want to check the area to the right and to the left of those. So you want to shade each of the end areas.
Yeah.
Okay, so
0.1745.
Yep.
Is that right?
And make sure we all know how to use the applet.
okay. We don't have to worry about, let's see. So it rounds, of course, to 0.175.
Yeah.
Yep.
So 0.175.
Yep.
Okay. Problem 4. Which of the following have a smaller standard deviation if 9 observations are randomly drawn from a population? So 4. Which of the following have a smaller standard deviation? Well, let's see. It can't be the middle one, right? Because the sample of the, when you take a sample, it doesn't have a titer. Isn't the
No, but
there's not enough information to work that out, is there?
No.
yes,
Yeah,
there
there's.
is.
If you let me see.
Sample means it's divided by the number of samples that you took out, so it's smaller.
Yeah.
It's divided by the square root of the number of samples, so it's smaller.
Right.
right, the standard deviation is smaller. So okay, so it would be that one.
So
the middle one.
Yeah. The distribution of the sample means.
Okay.
Which of the following will have a smaller standard deviation? Distribution. Yeah, it would be the sample means, because there's more of them.
Yeah.
Which will make that number.
Which of the following implies a spread?
Which one of the following results implies that the spread in X decreases as the sample size increases?
Let's see, is that the central limit theorem?
Yep. Because it becomes closer to the median. No, or is that the law of large numbers? Ugh.
That's what I'm reading now.
Which of the following implies that the spread or the distribution of the sample decreases as the sample size increases? Huh. It's not the central limit theorem. Let's see.
Okay, large is the standard deviation of those sample means will get smaller, or your mean will get more and more accurate. That's the large limit. Law of large numbers.
Implies that
The standard deviation of those sample means will get smaller, or your mean will get more and more accurate. The spread decreases. Yeah, that'd be a law of large numbers.
I think so too.
Central limit says as the sample size increases, the distribution of sample means will become more approximately normal. Ugh. The spread. So does that consider the spread, the central limit theorem? As the sample size increases? Yeah, as the sample size increases. The other one deals with sample means, so it is central limit theorem.
Because it sounds like when they use the word the spread, you're talking about
But if the
So in
spread
this-
decreases, then it gets closer to the population mean, which would be the law of large
Oh.
numbers.
That's right. Yeah, because yeah, that's right. Because sample means will become more approximately normal. Will get more accurate. More accurate is closer to the regular or the mean. Ah, I hate this one. I'm going to trust you guys on this one.
What is the spread in the sample?
Mean will get more and more accurate. Spread, it's going to come in tighter. It's going to
So
come in
is it
closer.
not the normal distribution? Well, let's try and think now, because the spread gets smaller. Yeah, I'm trying to.
Okay, so there's a sample size, large numbers. Large numbers. Per smaller. The mean will get more and more accurate. Wow, it almost fits for both. So I don't know what the
The large number one is that as the sample size gets larger, the sample mean gets closer to the population mean.
Which is what happens when the spread decreases. So that'd be the law of large numbers. That's what I think it is, but at least we get more than one chance.
yeah.
Which of the following results implies that the spread decreases?
All right, we want to go with law of large numbers.
Is it? So as the spread in the population decreases, the sample size increases.
Yeah, it's going to come in closer to the mean.
Yeah, isn't that the normal distribution?
So you could fit for that too.
Well, we've got 4 shots, so let's move on.
So as of right now, for the sake of just kind of talking through it, what's our argument for the central limit theorem?
See, I'm wondering if like the central limit theorem and the law of large numbers was covered in the last one. In this one, we used that little diagram to show more coming and showed how it became a normal distribution.
Yeah, see, my thing tells me it's the normal distribution just because as the spread of the people is, the normal distribution gets better. So instead of being left or right, it comes, I don't know.
It kind of piles up in the middle.
Yeah, I mean, it could also be the 68, 95, 97 rule, but that's already got a different definition. Okay, well, let's just pick one, and then whoever goes first will look what they chose.
Yeah, there's a good.
Okay, let's go to question 6. Diana earns a score of 160. Where's my Excel document?
Okay.
So the mean is 150. Oh, 150.8. And deviation is 8.8. And
So
earned a score of 160.
So for question, oops, hold on here.
So we're solving for the z-score.
Yep.
So everybody go ahead and do that, and we'll see what we all come up with.
Oh, I got 1.045.
Yeah, then it repeats.
Well, there you go, rounded to the 3rd decimal place.
So it'll just end up there. You guys all good with that?
Still working it out. Bye-bye.
I got 1.045455.
Yep, 1.04545, so 1.045.
Okay.
Is it not 1.046?
No, because the 45445 it just repeats, so you would round it down to. It would just round, excuse me, to 1.045.
Okay.
I believe, right?
Yeah, because the 4 wouldn't push the 5 up.
So the next one wants us to punch that into the z-score.
Right.
And then it said, what's the probability that a randomly selected student will score above? So we just want to shade to the right. Correct. So it looks like that area is 0.1480 or
0.148.
yeah.
Hold on. What is the probability that the random selected students will?
So you take your z-score that we just solved for,
Yeah.
punch that in and shade to the right.
What did everyone get?
0.148.
Yep. So we're good to go on to question 8?
Yeah.
Yep.
Sorry, what was the answer question? My app's crashing here.
For number 7?
Yeah, 0.148.
Yep.
Okay. My app,
It terminates right at that point.
Yeah.
At least on my calculator it did. Let's see. All right, so question 8 says a random sample of 5 students was taken and their scores are as follows. What is the z-score corresponding to the sample mean of these student scores? So we need to take those numbers.
The sample mean is 160.
That's the middle. Let's see.
Yep, the mean of those numbers, I just punched it into the statistics spreadsheet.
busy doing that now.
That comes out to 160. So 5 students, number, we use the z-score calculator with the number 5. So we take the standard deviation, find the square root of 5. Square root is 2.24 or 236, 2.236. 8.8 divided by that. 8.8 divided by
What was this?
36. Equals
Let's see.
0.7278. So 9.2. 2 divided by 3. 46.
So hold on here. I'm a little bit behind the 8 ball. So we need to find the z-score corresponding with that sample mean of the student scores. So the mean you said was 160.
Yeah, means 160.
What's the standard deviation? Let's see.
We have to
Okay,
put
standard
it in the app.
deviation is 8.8.
Oh,
Remember,
from
this
the,
is the same.
from the
Yeah, from the
previous
previous
one. I'm
problem.
sorry.
Well, the standard deviation is 8.8 divided by the square root of 5.
Yep.
Yeah, okay.
So then you still gotta take the mean, which is 160. So 160 minus 150.8 equals 9.2. Then you take the 8.8 divided by the square root of 5. That comes out to 3.7278.
I got 4.675.
Okay, hold on. Let's just do this again. So the mean is 160. Is that right?
Yes.
Standard deviation is 8.8.
8 divided by
The sample is what? 5. And it's x 150.8.
Okay, so I got a z-score of 2.3377
Yeah, 1. I got a score of minus 2.33771. But it doesn't matter.
So-
You can still use it to put it in the app.
Yeah, that's what I got too. So then we put that in the applet.
On the left-hand
Point.
side.
Two.
This
No,
one just asks for the z-score on this question.
Okay.
So what'd you guys
So
end up
let-
with?
Well, let's just confirm this quickly. Is the mean 160? The standard deviation is 8.8. The sample is 5, and x is 150.8. Is that right?
Wasn't it opposite to, let's see,
Random
because
sample.
you know,
The
yeah,
top
I'm
of the-
sorry.
The top of the fraction is 160 minus 150.8.
Yeah, because the
oh,
mean's going to be, the mean of the sample is the same as the mean of the parent population.
Right.
Okay, so yeah, so 160 minus 150.8, then divided by 8.8 divided by the square root of 5.
Right.
Hold on. What is the mean? The mean is 160.
Well,
150.8.
That's
The
interesting
value
because
is 160. That's the mean of the mean, which is 160.
doesn't the mean of the mean of the parent population
The mean of the parent population is the
is 150.8, right?
right. The value that we're inserting is the 160.
But
So let's see.
what is the probability that we score of 160?
look at my.
What is this z-score? Okay, so it says, what is the z-score corresponding to the sample mean of these students? So the sample mean for these students is 160,
Right.
correct?
Yes.
The standard deviation,
160 minus.
the standard deviation is 8.8. The sample
Yes.
size there is 5,
Right.
and
Yes.
the x is 150.8. Is that
No,
right?
150.8 is the population mean. The x in the equation is 160.
So then what's the mean?
I was thinking that maybe they're just kind of giving you this information to kind of throw us off, because I could be totally wrong. I thought that if you take a sample of something, that the mean of that sample is the same as the mean of the parent population. I know the mean of these 5 numbers, it looks like, is 160, but that's kind of, isn't that like a side note, kind of something we don't really?
No,
in
the
all my
means will
in
be
all
the
my
same.
in all my formulas, it's x minus the mean. So x would be the
Yeah.
sample of your means. So you got to take
Okay.
x, which is the sample of our samples, so the mean of our samples, minus the actual mean of the population, divided by the standard deviation, which is divided by the square root of the number.
Okay.
What you're talking about is the mean of all sample means. That's always the same as the mean of the population sample. But this is just the mean of these 5 numbers, not of all sample means.
Okay. Sorry, I'm throwing you guys off.
So I didn't see anything in the things where we didn't do for solving for z where we didn't use x minus mean.
Right. Yeah, so did we all get 2.3377?
I got
I did.
negative. I got negative.
How would you get
2.33.
I got 2.3377.
Yeah,
But
so I
that's
took-
because
You got negative because you reversed the numbers on the top of the equation.
yeah, because
Yeah.
I still believe it's 150.8 minus 60, because the mean is 160.
Is the mean that's the mean. we're solving,
Yeah.
or we're starting with X, which is the mean of the samples. So those 5 numbers, you get the mean out of those,
Yep.
which is 160.
Is that your X?
Yeah, that's your X. So X
Uh-huh.
minus
Since this
mean,
mean, because this mean 160 is greater than the population mean, which was 150.8, the answer has to be positive.
Okay.
The z-score has to be positive.
How did you work out 150.8 for the mean?
That's the population mean. It said it in the
that they
original.
gave us at the beginning.
Oh, okay.
From question number 6, right?
Right.
Yep, just above that.
Okay. Okay, then I'm in agreement. 2.3377, which will be
Yeah.
2.
No.
2.338.
Oh, yeah, round it off. That's right.
Yeah, I'll round it off now. .338. Okay.
I can hear them.
Now we solve for the probability, which is the percentage. We're now solving for the top part of the applet on question 9.
Yeah.
That put the z-score in and
What is the
shape
probability?
that over to the right.
Oh. That's a pretty small probability.
So 0.0097. Is that what everyone got?
Yep.
Well, it'll be 0.01.
Yep, 0.010.
Oh, no, hold on. No, it allows us to enter 4 decimals in this one.
Yeah,
Oh, it
we
does?
put the 3377 instead of the 338.
Yeah, so it's 0.0097, the answer. That's what I got anyway. Is that what everyone else got?
Yeah.
was-
Did it say to round? Let's see.
Yeah, they said 4
Round to
digits
the
there.
4th.
Everyone good with 8?
Yep.
I mean, with 9, sorry.
Yes.
Okay.
Okay, new set of information.
Okay, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of N is drawn of students. What is the shape of the sample distribution of the random variable
Normal.
X, which represents? So it'll be normal, approximate normal, won't it? It's a large,
Yep.
Yeah.
it's a large
One's
distribution.
nice and big.
Oh, hold on, I better record all those things.
Yeah. Okay, suppose the mean 3.5, standard deviation 0.7. (81) is our X, or N.
Is 81 not the sample? That's X, you're right.
Yeah, this is.
Okay. What is the mean of the distribution?
Wouldn't it be the same as the parent population mean if it's all
Yeah,
possible?
3.5.
3.5, isn't it?
Yep. Yep.
Oh, good. Okay.
Oh. Okay, what is the standard distribution? This one we have to work out by dividing. Oh no, hold on. What is the standard distribution?
So it's the standard distribution of 0.7 divided by the square root of 81.
Yeah. Just
Equals-
working that out now.
0.0777777.
It's the
0.7777.
0.07777.
So 0.778.
0.078.
Right.
0.078.
Deviation. So again, so I just got stuck here. 0.077. 4 digits. Okay.
It wouldn't be the 7 wouldn't round that up to 8.
It's 0.0778. Is that what everyone got?
Yeah, but shouldn't it be?
That's not to 3 decimal places. That's to 4 decimal places.
Okay.
Sorry. Thank you for catching it. I only read the first part where it says the answer is, and saw 4 digits there. Okay. What is the probability? Probability. .3.
Let's see. Julie.
So is this x minus the mean divided by the standard deviation?
All right, so yeah, so where are we all at right now?
It's the
Working out the
probability.
formula.
First, you got to solve for z, unless we count the z 0.0778.
I got
Needs to be less than,
negative
so we put in that.
2.56 for the z-score. Is that right?
What did you get for a z-score?
0.778.
Negative 2.56.
My z-score stuffed up. 3.3.
Asking for.
I had negative. I had a negative 2.5714.
I got negative 0.2851. That's 71.
Oh my goodness.
Okay, let me recheck this out. So to work out the z-score, it's the x minus the mean divided by the standard deviation. X
Well,
being observations.
The x is the 3.3, and the mean is the
Correct.
population mean, which is 3.5.
Correct. Divided by the standard deviation of 0.7.
No, I thought the standard deviation was 0.078
Okay, maybe I read it wrong. Let me go back.
from the previous question, remember?
Yeah.
Maybe I'm doing this wrong.
0.078. Negative 0.2 divided by 0.08. Now that's solving for z. We already solved for z. No,
We
that's
gotta solve for the z-score to get the probability, right?
Yeah.
Okay, so is it negative 2.56?
Yep, that's what I got.
Okay,
2
So
minus divided by.
put that in the applet.
Should be 0.9949. Or basically 99.5%.
Well, let's see, what is it asking for? What is the probability? Will be greater than 3.3.
It's asking what the probability is, so that's the top part.
Yeah, so 0.6010.
0.0052 for the area, for the probability.
Hold on.
I selected the middle section and the section to the right.
It's less than 3.3. So it's going to be the leftmost section.
It says will be greater than 3.3.
No, it says how many will be less than 3.3.
It will be less than 3.3. The probability of putting your z-score of 2.572.
Yeah, I'm on 14.
2.572.
Okay. It's exactly the same question on 13 and 14. My mouse keeps scrolling too quick. Okay.
We want less
So 0.
than,
So it'll be 0.399.
I got
Right.
0.9949.
Oh.
What'd you guys get?
Are we all talking about question 13?
Yep.
Oh, we on
I got a
13?
probability of 0.005.
How much?
0.005.
Oh, no.
No, it's less than 3.3.
Right. Which would make it small.
I got.
Let me see what I'm doing again here. What was
I
the population mean is 3.5, and they're asking if it's going to be less than 3.3. So we're going to shade in the far left
Never
side.
mind. I'm sorry. My bad. I shaded the wrong thing. I was going to the left of the positive number.
Okay.
So 0.0051.
Okay. Hold on. How did you guys get that? What is your z-score?
Negative.
Z-score is 2.564.
I got negative 2.572.
So we got two different z-scores.
Like I said, you have to use your whole the 0.07777 thing to get the correct z-score. If you take original thing 0.7 divided by the square root of 81, which is 9, divided by 9, then you got 0.07777 that goes all the way down to 8. And so if you save that, and then you take negative 0.2, so 0.2 negative, and you divide that by 0.0777778, you get a z-score of negative 2.5714.
Say that again. Negative?
Negative 2.5714.
2857142857. That's the long thing. But if you put it in, it ends up being a 2.571. But negative.
Okay, so what's everyone's
2.571? 0051.
Say it again. 0.
He's talking.
I got 0.0051.
That's what I have. 0051. 0.0051. Yep.
Okay, yeah. Yes.
It's a good thing we got everybody to cross-check.
It's amazing how much that z-score changes it if you don't round it off.
Yeah.
Oh yeah.
Okay, so so for number 11, sorry to backtrack, I put down 0.078.
Yep.
When it's
For number
rounded.
11. For number 11 or 12?
I put
I thought that's what we decided for number 11.
11 is 3.5. That's not
11 was 3.5.
Sorry, I must have gotten skipped on one. So I'm sorry, the mean. Okay.
And then number 12, I got 0.0778 because of the fact that the other 7 rounds that previous 7 up to an 8.
You mean
Rounding to
0.078? You just said 0.077.
0.07.
Yeah,
So we're only doing 3. Oh, crud.
0.078.
Yes.
And 13, to see what's the probability. The probability was 0.9949. Is that what you guys got for number 13?
No.
Nope.
0.005.
Nope. You got to go to the negative number.
Okay. Oh, shoot. Sorry.
Yeah, I made that mistake earlier, so. That's why we're here to correct each other.
I need to pop that into the applet. Sorry, I got switched around somehow, and so I was.
I think before we post, let's just go through everyone's answers, make sure they got the same.
Yeah.
I was working in 14 and not 13.
Okay, so 13.
Yes.
What's the z-score that we have in the applet right now?
Negative
A zero.
2.571.
Okay.
Yep.
Cool.
Right?
Yep.
Yep.
Okay, thanks. Had to get back on track
So
there.
did you get 0.0051?
I did.
Okay, good.
5-1.
All right, 14.
14, just add the middle one. Or the middle one and the one to the far right.
Yeah.
Greater than 3.3. Which is
I got
0.9949.
That's it.
Which is 1 minus 0.005. Another way to do it.
Yeah.
Let's see. All right, so question 15.
Yeah. Let's put this down. Okay. Okay. So standard deviation is 26.7.
This one's going to try and, let's
48.
see,
Sample mean.
which is your X. That's your X.
The sample mean.
Or X bar. Yeah, your X bar. So the 177.6 is going to minus the mean, which is 185. 77.6 minus.
.6.
So it's going to be a negative number.
Yeah, I got minus 1.92018. Yeah. Then you got to find the probability.
I'm going to try that again.
Yeah, once you solve for Z, you're good with that. So clear plus.
So what'd you get for the for that z-score?
6.7.
I got a
Z-score.
negative 0.277.
No. I got minus 1.92018.
I got 3.8538.
Hold on. So I got negative 7.4, So 0.4 negative divided by 3.85381304684075
Oh yeah, I'm
equals
talking about the standard deviation. Never mind.
negative 1.920176.
I got 1.8.
So
Yeah.
1.920.
Yeah.
Negative 1.920.
Yeah.
So if we
that's
put
what
that in our applet,
Yeah. Well, I need to read what the question is first. Find the problem.
1.920. Ability.
Says
The
this,
probability that a random sample will have a weight that is extreme or more extreme, either above or below the mean.
Negative 1.92 is what I have.
yeah, that's right.
Is what I have for the
I've got 0.5761
As your probability,
for my probability.
I've got 0.0549. Let me read again what I did here.
Yeah, we're
Find
looking
the
for probability.
of a random sample of passengers that have a weight that is as extreme or more extreme, either above or below the mean, than was observed in the sample. So I took the far left and the far right and added them together.
How do you get, the far left?
Let me just make sure.
Extreme or more extreme?
0.0549.
Yeah, that's what I got.
Yeah, that's what I got too. Well, we got to round that to 3 decimal places, right?
How did you guys
Yep.
get that with that? Oh, I didn't put in the right Z-score.
That's what kills me. You do a tab and the Z-scores changes.
Negative.
So we're using a Z-score of 1.92.
Yeah.
Okay.
0.0549.
Yes.
Yeah, but it's 0.55, eh?
0.055. Yeah.
3.
Right.
Yeah.
0.055.
0.055.
Yep.
Yes.
0.55.
Okay, so help me out here. Where am I going wrong? So I came up with the same Z-score of negative 1.92.
Yep. And then the
Read
question,
the note part.
it says to use the extreme both far. So the extreme is always on either the far ends. And this asks you for the both extremes. So you got to click the area on the far left and the far right.
And the far right. Okay, I only had the far right.
Okay.
Yeah, and that's noted in the note part. Is extreme or more extreme?
Okay.
Okay, so we go up to question 3 and someone want to read through all the answers just to make sure.
All right, scroll up to 3.
Okay, so number 3 was 0.175.
Yep.
Then we decided that for number 4, the distribution of the sample means was the correct answer.
Yep.
Number 5, we decided that the central limit theorem is what we were going to try.
I went with normal distribution.
Yeah, I went with normal as well.
Large numbers.
Okay,
Yeah,
so
we'll find out when whoever decides to be the first.
we'll go with normal distribution for that.
Yeah.
Then see question 6 had 1.045.
Yep. Yeah. Okay, so let's read that.
Number 7 had 0.148.
Yep.
Let's see, what did I just say? I said number 7, right?
Yeah.
You're on number 8 now.
2.338
Yep.
for 8. 9, 0.0097.
Yep.
Number 10, approximately normal.
Yeah.
11, 3.5 average
Yeah.
GPA or mean. Number 12, I had 0.078.
Yep.
Number 13, 0.0051.
No, don't put the 1 in.
Round it off.
Oh, because to 3,
Oh, 3 decimal places. Thank you. Good.
so round it down there. Okay, that makes sense.
0.005.
Question 14, 0.995.
No. Yes. Whoa, I almost got that one wrong.
3 decimal places.
0.995. Jeez.
Then question 15, 0.055.
Yep.
Correct.
All right, I'm going to go ahead and submit mine. See what happens. If it'll do anything for me.
Just be careful. We don't want to
Save all
fly.
your responses.
Yeah. And don't fly out of it because we want to know which one you got wrong,
Yeah.
Right.
if any.
Or all right.
Okay, so it says we missed one. Got a 94.12%. So
I bet we can guess which one it is. Number 5?
Good.
No, I reckon it's 4.
yep,
Five.
number 5.
Okay, so go ahead, Brandon. You want to switch it to the law of large numbers and
Yep,
try it?
I'll turn it in, see what happens.
Watch me get it on the 4th one. You
Yep,
got
that's it. We're good.
That was 100 law of large numbers.
Yep.
Good job, Brandon.
nice.
All right, so we're at 100%.
I have got to figure out a way to figure that out.
Yeah, those ones are terrible.
Yeah.
Even on the homework, I got it wrong. Not the homework, on the, whatever it was, the individual
Preparation?
work. Yeah, I got it wrong there again. I was like,
I struggle with it. All right, 100%. All right.
Right.
One good thing, guys, is I think between all 4 of us, we're getting this stuff. So when it comes time to do our project, we should be good.
Yeah.
Okay. I'm going to go ahead and stop broadcasting.
All right.
Perfect.
All right. Thank you.
All right, guys. Thanks.
Cheers,
No
everyone.
problem.
See you guys
See you
next
next
week.
Tuesday.
Okay.